Good day, everyone. So we are reviewing Wetzel's Limnology textbook, the fourth edition, and we are on chapter 4. And we are more specifically looking at rivers and stream characteristics, and the section D, channel morphology. But before we do that, let's look at a couple tables and figures. So table 4-4, drainage basin and river channel characteristics. So in here we have definition of topographic characteristics for various parameters that defines a river channel or drainage basin. So for example, we have the basin length, which is L to the sub B, straight line distance from basin outlet to the point on the drainage divide used to determine the main channel length, LC. We have basin width, we have the basin perimeter, the basin land slope, the basin diameter, which is, for example, the diameter of the smallest circle that will encompass the entire drainage basin. We have the basin shape, the compactness ratio, which is the ratio of the perimeter of the basin to the circumference of a circle of equal area computed from A and P to sub B as follows. CRB is equal to PB divided by 2 pi A to power of half, to 0.5. Main channel length, the length of the main channel from the mouth to the drainage divide, the main channel slope, SC, and the sinuosity ratio, which is the ratio of the main channel length, LC, to the basin length, LB. Figure 4-7 illustrate the stream ordering according to the Strattler method that we reviewed yesterday. So what we see here is we have a first order stream in the ones. We have then a second order stream where two streams meet that creates a second order stream. And then we have a third order streams where the two meets. Then we have figure 4-8, which are common types of drainage network patterns. So we have the dendritic pattern, rectangular pattern, the radial pattern, the centripetal pattern, the trellis pattern, the parallel pattern, the annular pattern, and then the deranged pattern. And then lastly, we wanted to kind of look at the distribution of the various channel configuration depending on where they are within the watershed. So for example, here we have different scales. So we have sediment supply, low to high, dominant texture of floodplain sediment, fine to coarse. And then on the y-axis, we have channel sinuosity and stability, low to high. And then this is the stream bed gradient, low to high. And then this is the ratio of bed material load to total sediment load. So for example, for a meandering channel, we have tortuous, serpentine, confined, wandering. And then we have the anastomosing, and then the braided channel. So if we look at the legend to the figures, the top panel form and gradient of alluvial stream channel and the type, supply, and dominant particle sizes of sediments. Great variation in channel patterns exist, and the figure depicts examples within the range of channel types and the extent of anastomosing around channel islands. Bottom panel, 3 examples of meandering, anastomosing, and braided river types. So this is the meandering river type, which is very common, and the anastomosing river type, and then this is the braided river type. So there's somewhat of a similarity between the braided and the anastomosing type. And part of the difference is the permanency of the land that is locked between either anastomosing arms or the braided channel arms. And we'll review that in a minute, a little later. So, channel morphology, D. The trough in the landscape, usually within a valley that contains the flowing water, is the stream or river channel. The channel is described physically in terms of length, width, depth, cross-sectional area, slope, aspect, and other parameters. The channel is typically bordered on one or both sides by a flat area called the floodplain. Much of the soil of the floodplain is connected hydrologically to the water of the channel. River channels can contain low to moderately high discharges without overflowing the banks. A bankful discharge is a flow that fills entirely the cross-sectional stream channel without overflowing onto the flood channel. The bankful stage, namely the water level at which the river begins to spill into the floodplain, is equal or exceed on average once every 1.5 years. Therefore, discharges are usually much smaller than at the bankful stage. River channels rarely flow over an even downward gradient and are never straight over an appreciable distance. As the energy of flowing water is expanded against irregularities in channel morphology, with time there is a tendency to erode the channel to produce a more even gradient and a more uniform dissipation of potential energy per unit length of stream. The bending and meandering of a mature channel approaches the theoretical equilibrium of an even energy gradient much more closely than do straight channels. Meandering channels also increase the total volume of the channel and thus its capacity to receive and transport water from a river's source to its mouth. Rivers are erosional where moderate to rapid flow prevails and are dispositional of silt and organic particles in sections of slow currents. River channel characteristics are constantly changing in relation to variables of discharge, width, depth, substrata resistance, and transport of sediments. The introduction of a dam and its associated reservoir management practices can strongly affect these dynamics. Stream and river channels gradually move laterally within the floodplain because of the erosion and deposition of the sediment. Old, abandoned portions of river channels are common among most floodplains. As a particular feature, channel bars are accumulation of bed materials below the average water surface level that often move or are deformed by changing water velocities and that may emerge during low water levels. The morphology of rivers has been classified and organized on the basis of many criteria of fluvial morphology, such as drainage basin, area, discharge, width, depth ratio, bed material size, or channel slopes. Most rivers and streams flow in valleys that exert some lateral and vertical control over the river. Reaches of lotic ecosystems are considered constrained when the valley floor is narrower than twice the active stream channel width. Constrained river systems occur where natural geological or human-made features constrict the valley floor and limit lateral mobility and the development of adjacent plant communities. Rivers in valleys without contemporary floodplains are also called incised or entrenched. Canyons are an extreme case of river incision. Unconstrained river reaches have valley floors that are wider than twice the active channel width and lack major lateral geological or artificial constraints. Most streams and rivers are of this type and are characterized by active migration of the channel that expand into extensive floodplains and often form braided channels. The extent of the lateral constraint depends on river size and is quite variable from stream to stream as well as within the same river ecosystem. The forms of river channels, as seen above, also termed river or channel platform, are very diverse and deviate from four general classes: straight, meandering, anastomosing, and braided. These four platform types are often used to indicate general trends of stream parameters such as erosion potential, sediment supply, effects of vegetation, and sensitivity to geomorphic disturbances. It should be emphasized, however, that such classification system, while informative, cannot fully represent the great variations within channel patterns and should not be relied on to predict specific local situations, as different climate conditions and hydrological regimes can strongly affect these parameters. Although most rivers flow in valleys, exceptions are common, such as rivers on deltas, fans, or broad plains. Deltas are river-deposited continuation of land built by sedimentation out into a body of water. Fans are alluvial fan-shaped surfaces deposited where a narrow valley emerges onto a broad surface. Broad plains are usually alluvial, lacustrine beds of drained lakes or emergent coastal plains. I wanted to ask the difference between an anastomosing and a braided river channel, or anastomizing, I should say, and a braided river channel in ChatGPT. So let's find out. So an anatomizing river channel is characterized by multiple interwoven and often intricate channels that branch and rejoin, resembling a complex network. The channels divide and reconnect in an intricate pattern, much like veins in an anatomical structure. Formation. These channels typically form in environments with high sediment supply and moderate to low flow, such as floodplains or deltas. The intricate patterns are often a result of varying sediment loads and water velocities. Characteristic. Channels may split and recombine in a complex, often orderly pattern. They usually maintain a continuous flow of water across different channels. Less braiding compared to braided channels with more defined permanent pathways that interconnect. A braided river channel. A braided river consists of series of interconnected shallow and frequently shifting channels that are separated by small islands or bars of sediments, often sand and gravel. These channels constantly split and rejoin, forming a braided pattern. Braided channels form in areas where there is a high sediment supply combined with a variable flow of water, such as mountainous or glacial regions. The high sediment load and low bank stability cause the river to split into multiple channels. Characteristics. Numerous temporary channels formed by the shifting of sediment bars, often found in regions with steep gradients or where the river carries a large amount of sediment. The flow is highly dynamic, with channels changing frequently. High variability in channels width and depth due to constant changes in sediment deposition and water flow. The key differences: channel configuration. Anatomizing channels are more interwoven and structured, while braided channels are more chaotic and shifting. Sediment behavior. Braided rivers are dominated by the formation of bars and islands, whereas anatomizing channels have more defined interconnected water path. Flow stability. In anatomizing channels, water generally flows through a more stable networked system, whereas braided channels have frequent changes in flow directions and channel formation. Both types are influenced by sediment loads, water velocity, and bank stability, but differ in the way the river reorganizes and deposits sediments over time.